Hello and welcome back. In other videos, we show you how to load data, create a model, and how to apply a model. In this video, we're addressing the topic of training and then testing a model so you can find out how accurate your predictions will likely be. If you want to follow along, you can download the data file and the processes which we're using and import them. The data loading process video will show you how this is done. So, let's get started. First, we're going to reuse one of the processes which we created in another video. We're going to our Processes folder and we will select 02 Build Decision Tree, which is from the Creating a Model video. So let's double-click on it to load it up and let us take a look at this process. First, we load in some customer data, and in that customer data we have examples that have either a churn or a loyal label, but there are also some with missing values. Since we want to first build a model, we only want to use examples with labels. We need to filter out the data with missing values before we build our decision tree. So what this process does is it creates essentially something called a training data set. In the Applying the Model video, we show you how to score the data, which means we actually take the examples without labels and apply our model to predict our new customers' loyalty, putting or segmenting those unknown customers into the loyal or churn buckets. But the issue with that approach is that we can't really assess the performance of our prediction as we don't have any information as to if our predictions are actually right or wrong. So in order to test our performance, why don't we build and train our model first on our example set with known labels, and then we can try to predict those same known labels with our model. So let's go ahead and get an operator called Apply Model. We need to connect the Decision Tree Mod port, stands for model, to the Apply Model operator's input mod port. Okay, excellent. Now, the second input port is called UNL, which stands for Unlabeled Data. So it is requesting the data on which we want to apply our prediction. In our case, as mentioned, this is going to be the same examples set which we used to build the model. So let's drag this example port over to here to the Unlabeled port, and like in the Applying the Model video, we will get a little icon to multiply the data. This will allow us to use the example set for training and testing, so let's click on that. Excellent, and now let's connect the labeled output to the results. So what did we just do here? Let's take a moment to recap. We loaded in the data, we filtered out the unlabeled examples that don't have loyal or churn, and thereby we created a training data set. We fed the training data into the decision tree and built the model, but we kept a copy of it to drive it down to this branch here, where we took that same example set and applied the model to it to create predicted labels so we can finally compare them both. All right then, let's see how our model does, and let's hit the Run Process button. So now let's take a look at the results and compare the label columns. Loyal, loyal, good, the prediction was correct. Churn, loyal, the prediction was not correct here. Loyal, loyal, prediction was correct. Loyal, loyal, prediction was correct. Now to get an overview, it would be best to compare all the previous existing with the predicted labels and add them all up. And from there, you could get a percentage on how accurate your model is. Well, you can do this by hand, or you can let the computer and RapidMiner do that and get the insight much faster. The key is to measure the performance, and as you have certainly already guessed, there is an operator for that. So we will now switch back to our design view. When you search for performance, you'll see a whole list, but we will use the simple performance operator and drag it to the very end of our process. Before we run our updated process, we might want to take a moment to save it. I'll call it 04 Testing the Model. Now let's hit F11 to rerun our process, and we see that our accuracy is 85%. Not bad at all, but wait a minute, is this really a reliable measure for the accuracy of our future predictions? If you think about it, what we just did is we've provided 100 questions to a student and then tested them on their answers. But did we really assess our student, our model, on the right challenge? No, the only thing we tested now is how well can this student reproduce answers to known questions. We just looked at the so-called training error, but what we really want to know is the prediction error, which describes how well will the student or our model do with unknown questions or an unseen data set. Well, we will show you how you can achieve that in the validation video. Thank you very much for watching.